All right, kia ora everyone. Welcome to the second of these mini online lectures. And this one's going to continue on from the first one that I did that I hope you have all managed to watch. And it's going to continue to talk about the evidence for common mycorrhizal networks mediating communication between plants. And so once again, as for the previous one, I'm going to switch my video off and we're just going to look at the slides. And I'll try and do a better job of reminding everybody what slide we're up to. Okay, so let's turn my video off. All right, so as I said, we're going to talk about another study that looked at whether common mycorrhizal networks mediate communication between plants. And the basic idea of this study and this experiment is similar to the last one, but there are some key differences that I'll go through. So in this case, what they did is they just used pairs of plants. One was being eaten, and then they looked to see whether plant defense responses were initiated in the one that wasn't being eaten. And these were tomatoes. And for these tomatoes, they infected them with an arbuscular mycorrhizal fungus, Funneliformis mossii for what it's worth, which is kind of what these potato-shaped things down here are indicating. These are the spores, actually, of this fungus that we use to inoculate it. The pink lines that are shown here are indicating whether a hyphal connection is allowed or not. And like the last study, they used a mesh, and the dotted ones are where the mesh is coarse enough to allow hyphal connections to form to grow through the mesh, not roots. So the roots are excluded in all cases, but in these cases, the hyphal connections can form. The solid line is one where the mesh is too fine, and so hyphal connections can't form between these two plants. And then what they did is their herbivory was being eaten by a caterpillar. So they put this caterpillar onto the plants. And so they had 4 different treatments, similar to the last experiment, A, B, C, and D. In A, they have the caterpillar, they have the mycorrhizal fungus, and they allow the common mycorrhizal network to form. B is the same, except they don't inoculate these plants with the mycorrhizal fungus, so there's no common mycorrhizal network can form. In C, it's the same, except that their mesh is too fine, and so now the common mycorrhizal network can't form because the hyphae can't pass between the two plants. And then in D, it's the same, except that they don't put the caterpillar on, so they put the common mycorrhizal network, but they don't put the caterpillar on, so there's no herbivory response that the other plant is detecting. So that's the experimental setup. Let's go to slide number 2 now. And what I want you to do is think again, just like for that first experiment, think of what the point of doing these different treatments is. And so for each of these, A, B, C, and D, come up with a justification for why this particular treatment was done. Now, unlike the last lecture, we're not going to do that in class today. I'm going to let you guys go away and do that in your spare time. And as a spoiler alert, this is actually what I'm going to ask for the quiz for this particular mini lecture. The other question that I'll ask is, do they, in other words, the people who did the experiment or this experiment, need a positive control? And what could a positive control in this experiment be? So I'm not going to answer either of those 2 questions in this lecture at all. I'm going to set those as quiz questions, and you can come up with your own answers to those. Once again, it's important that you try this out and get familiar, because these are the kinds of questions that you might see in your exams. Okay, so let's move on. So now we're up to slide number 3, and what I want to do in slide number 3 is go through the results that they found in this experiment. And a little bit like that previous experiment, if we just look at what's going on here, it's not particularly obvious, so I'll try and explain what they did. So fundamentally, what they're doing here is they're measuring the enzymatic activity of enzymes that are produced by plants as defense response enzymes. and they measure the activities of 4 different enzymes, and that's what's indicated by A, B, C, and D in these graphs here. And so these names here just represent the different enzymes that they're measuring the activities of. We're not going to cover what these are. It's not important for you to know what they are, but just to know that these are enzymes that people think plants produce as defense response enzymes. And therefore, if a plant is turning on a plant defense response, we would expect the activity of these enzymes to increase. And what they're doing here is they're measuring the enzymatic activity of these enzymes in the receiver plants. So you've got the one plant that had the caterpillar on and the one that didn't. And so you had the pairs of plants, one which had the herbivore and the other that didn't. And so this is the responses in the plants that didn't have the herbivore, so the receiver plants, in other words. And what each of these lines represents is one of those 4 treatments. And so A, B, C, and D is indicated here, and for your ease of reference, I've indicated what those mean here. And so A, for example, is where there was the avascular mycorrhizal fungus, where there was the caterpillar, and where there was a common mycorrhizal network allowed, and et cetera, for B, C, and D. And so what you can kind of see here is that in each case, the treatment with the highest enzymatic activity is A, and that's where there's herbivory and there's a common mycorrhizal network. And so this supports the idea that there is communication that's mediated by the common mycorrhizal network. Now, one of the things, if you look at these results, is how convinced are you by that? And I would say that in some cases it looks pretty convincing. So in A, for example, the LOX, what they're measuring here is this is the number of hours after insect attack. And so at the 6 and the 12-hour time points is a pretty convincing response when you have herbivory and a common mycorrhizal network. You don't really see much change for any of the other treatments. A little bit the same for C, but in B and D, it's less convincing that there's any particular response. Now for D, it's kind of interesting because 2 don't really have any particular response. A does, but the other one that has a bit of a response, although not as great as A, is D. And that is where there was the fungus and there was a common mycorrhizal network allowed, but there was no caterpillar put on the donor plant. So in this case, there's no herbivory signal for the plant to send. And so what you could do is you could think about what these results might mean and what they tell you and how convinced you are by them. Okay, if we go to slide number 4, one thing that I'm not showing you is another test they did. So they did these tests where they looked at the plant defense response enzyme activities. But what they also did is they put caterpillars onto the test plants, so the receiver plants, and looked to see how much they grew for a certain period of time. And what they found was that the caterpillars that were put onto the plants that had a common mycorrhizal network and herbivory with a avascular mycorrhizal fungus were smaller than the rest of them. So this was treatment A, and so treatment A caterpillars are smaller than B, C, or D treatment. And so remember, these are the ones that these are the plants that are being signaled to by the ones that were being eaten in the first place. So they let the ones get eaten in the first place, potentially signal to the second ones, and then after a period of time, put the caterpillars on, leave them for a period of time and see what the weight is. And the idea behind this result is that if a plant is producing anti-herbivory defense responses, then the caterpillars are likely to eat less and therefore grow less and therefore be smaller. And so the idea here is that the results are consistent in that the caterpillars are smaller, perhaps because they're not eating as much, because where there's a common mycorrhizal network and therefore communication of herbivory, more plant defense responses are being turned on. So together, these results suggest that the plants initiate defense responses to signals that are based on receiving those signals from a plant that's being attacked, and that those signals are being transmitted through the common mycorrhizal network. And together, this study plus the previous one kind of provide consistent and complementary evidence for common mycorrhizal networks mediating communication between plants. So they were different experimental designs, different organisms that were used, different measurements of plant defense responses, but they had fairly consistent results, suggesting that maybe there is a role of common mycorrhizal networks for facilitating communication between plants. Anyway, I hope that this gives you some sort of insight into the ideas around how you can design an experiment, what kind of controls are needed and how you can interpret results based on those controls, looking at results and seeing whether you believe them to be true or not, as a way of testing an idea, in this case, whether there's a common mycorrhizal network mediating communication between plants. What I want to do in the last little section here is tell you hopefully a different way of thinking about things. So if we go to slide number 5, this is a slide that I showed before. It shows these trees and these plants. They have these mycorrhizal fungi in the ground that are making associations and are creating networks between them, mostly underground, but every now and again the fungus pops up in the form of mushrooms. So this is the kind of way we look at these things, and we think that, you know, the fungi are just there and the plants are forming these associations and allowing the fungi to get a bit of food. But what I want to do, if we go to slide number 6, is let's turn this world completely upside down. And so rather than thinking of it from a kind of above ground terrestrial state, let's think of it from the perspective of the fungus, from a soil, from an inside the soil perspective. And so what I would like to suggest here is that rather than thinking about the fungi as being these passive kind of things in the ground that are, if they're lucky enough to be near a plant, they can form an association, we can instead think of them as kind of farmers or milkers. And so what they're doing is they are choosing to make mycorrhizal connections with plants, and they are using those to obtain food. So they're kind of milking those plants for the nutrients that they get. And those fungi, if they don't particularly like what they're getting from one plant, they can maybe give up that association with that one plant and move on and form associations with a different plant. And so they can kind of pick and choose the trees that are giving them what they want the best. And so in this way, they're kind of forcing, because the plants get benefits from the fungus, they're forcing the plants to give them a good deal in terms of the sugars that they receive from the plants, so that the plants will then be chosen by the fungus to form these associations, and the plants will therefore get those benefits. So hopefully this is kind of a provocative view of soil ecology and plant ecology that is rather fungal centric rather than being plant centric, and maybe an interesting way for you to think about things. So that's all I want to say for this section on mycorrhizae. So this finishes the section on mycorrhizae. And in the next set of mini lectures, I'm going to talk about endophytes. Once again, if you have any questions or comments about anything I've covered here, then please direct them to Piazza.